So we are starting with the lightning talks. First up, we have lightning talk by Jitin. Stage is yours.
Good afternoon to all of you. My name is Jitin, and this is Praveen. We're going to tell you about a device where you can use Python to control real-world events and also measure real-world events such as physical parameters, like what is the temperature in this room. You need to get the readings from a temperature sensor onto your Python library. So let me introduce to you QtPy. This is a simple Atmega32 board, which is connected to your computer via USB. And we built a PyQt app around it, which speaks to this device, and you can directly control it. Like, for example, when I toggle these bits here for the register port B, this is just technical jargon in embedded systems, you can see the LEDs go on and off in the video stream. I think, can you, like, yeah. Here, so I'm just toggling bits here, and it results in something in the hardware. So basically, I have a bridge from a small Python library to a hardware device. Now, if I have that bridge, I can extend it further and deal with sensors. Like, for example, this tiny little bit here, this small board here, that has a pressure and temperature sensor, the silver thing sitting on the PCB. And here, I can scan for connected sensors on this device. And this particular sensor measures pressure as well as temperature. So what you see right now is 907 millibars of pressure and 25.23 degrees of temperature. And if I record this information, this is temperature. If I touch it with my finger, you can see the temperature goes up because my body temperature is higher. And similarly for pressure, it's about 900 something millibars. Let me just zoom in and try to figure out what the least count of this thing is. There you go. So that's pressure. Now what happens if I lift this sensor to a certain altitude? Will pressure go up or down? This is not an interactive session, so let's just visualize it. I've picked it up, pressure goes down, atmospheric pressure. So you don't need to go to the hill stations, you can just see it. If I drop it to the ground, pressure is higher. So atmospheric pressure is dependent on the altitude. Now, I've got another sensor sitting on this. This is an accelerometer, which is what is on your phones for detecting the tilt angle of your phones, right? When you play games, this little IC is how your phone knows. Now, I'm going to use it for a small physics experiment. Let me just pull up the control panel for this. So you see, it measures acceleration on 3 axes, and it also measures angular velocity. Now, when I record this information, and this thing is oscillating, if somebody asks me what is the frequency of oscillations, so I have the angular velocity plotted as a function of time, right? Now, what I can do is, I can take these raw data points and use SciPy to do a sine fit. So all you need to do for this sine fit, it's 1.546 hertz, okay, for this large amplitude thing. So all you need to do for a sine fit is you need to define an error function, which is a sine omega t plus phi, that's your standard sine function, and scipy.optimize.least square will do the least square minimization fitting process. So yeah, so you can take raw data and extract a lot of information from that. Is somebody going to ring a bell? Or we can move to the next one. What happened to the camera thing? Yeah, so this is all designed in KiCad, and what you're looking at is the KiCad drawing for this board. And KiCad is pretty fantastic for designing circuits. What happened to? Yeah, okay. I've got one more demo before I wrap up. So the previous one was a bare metal thing. Is that the thing? Okay. The previous one was a bare metal thing, but if you extend that to include more analog electronics and stuff, you can make what you see on the screen here. That's a small magnet in the center, and these are 3 coils. So you've probably studied that if a magnetic field changes in front of a coil, an EMF is induced. So this little instrument has a 3-channel oscilloscope inside it, and it's going to try and measure the induced EMF when the magnet moves. So just put 3 channels here. The magnet is not moving, but let me just increase the time base a little bit longer and zoom in. Right, so when the magnet moves, you'll see some variation. See that? There you go. Now, if I want to make the magnet move continuously, it's mounted on a motor, which is supplied power from here. There you go. Just zoom out again. Yeah. There you go. So you have a 3-phase AC generator, and fitting with sine will tell you that the frequency of rotation is 8.5 hertz. I think, yeah, with this I'll conclude. The bell has gone off twice. Thank you.
Can go on. Next up, we have SM Anthony. Over to you.
Hello. Yeah. So good evening, all. So, how was your day? First, I hope a lot of you got to learn a lot of different things from different talks. So one of these talks, if you remember, so it is about. So in the era of LLMs, so one of the things that we have to really think about is the training cost, right? We have, of course, you need a lot of GPUs to host these LLMs, and to train them, you need even like exponential amount of GPU VRAM to train the LLMs. So yesterday we had a talk, and it was a really good talk. It was about it was about LoRa. It's a low rank adaptation. So today I wanted to have a little bit of light shed on something called QLoRa. So it's essentially like we have quantization, right? So the quantization is applied to when you train the model. The model is the quantization takes place during the training as well. So I will go into, so I think most of us who have been working on the LLM side would be aware of Hugging Face. And so they have done a really good job of integrating state-of-the-art papers into their package. So I would really recommend looking into it. So I have a little demonstration, in the sense, a little comparison. So we have this website called LLM Check. So of course, it's a meme over there. You know, it's either you are you are GPU rich or you are GPU poor, right? So let's take, so one of like a really good thing about working with open source models is that number one, you get privacy. Number two, as spoken about throughout our session, Llama 3 and Llama 3.1 has come so far into like democratizing LLMs for the normal person, right? So these are 8 billion models, and for reference, so this is the total size of the LLM, and if you look at the if you take the training cost, if you do it in full method without any LoRa or without any QLoRa, any techniques, if you look at the full method, and in about, of course, the prompt length is going to be playing a huge factor here. So the prompt length is very important. But let's say for this purpose, on average, our prompt length would be 5,000, right? And of course, tokens to generate would be nothing. And we enable gradient checkpointing. If you look at the GPU memory requirement, it is almost 98 GB, right? So what you can, as you can see, this is the GPU requirement, and it is 98 GB. And I don't like, it's very hard to like pair in different GPUs and to have 98 GB. So what we can do is, there is, of course, LoRa. If you use LoRa, it is decreased to 52 GB, and which is great by itself. But when we go for QLoRa, we can even decrease it even further. which is 43 GB. So sort of what I'm trying to demonstrate is that if the use case is such that you have a good foundational model and you have your own corporation data or data that you want to train the foundational model on top of that, QLoRa comes a long way, and you can easily train that. And this is, if you look at AWS clusters, you can find 64 GB for a normal cost. And this is the paper behind it, and you can read through the article if you want. And sort of, QLoRa is just that in LoRa. So in quantization, what happens is that every model, the parameters of every model is stored in 4 bytes, and QLoRa brings that to 4-bit. So thank you for the 1 minute. So yeah. So the point was with QLoRa, it quantizes it. So there's a data type called NF4. So it quantizes it to 4-bit, and sort of that reduces your GPU, the amount of GPU that you need divided by 4, right? And that is in terms of inference. Like, you can check out this website. It's called, you can just Google it, GPU poor, and you will get it up. And even in terms of inference as well as in terms of training, it's accessible, right? So one thing with LLMs, like throughout the years that we have seen, is that it is becoming more and more accessible. Even in one of the talks, we talked about paged attention, and that is really a game changer. And yeah, shout out to Hugging Face, and should really try it out. They also have an inference engine, TGI, and yeah, hope you learned something from this lightning talk. Thank you.
Yeah, next we have Ramki.
So we have this project called Instruct Lab. It'll be the lightning of the lightning talks. If you want to try it out, use pip install Instruct Lab. But I'll tell you what this one kind of solves is. So there's a lot of talk about open source large language models, right? How many of you are using any of the open source large language models? One, okay. The proprietary ones like ChatGPT, Gemini, what thing? So, okay, open source has 4 fundamental pillars. Like, you should be able to study, modify. Another one, anybody? Use and share, okay? So the so-called open source large language models, how many of you have tried contributing to it? Like, so the way in which you can contribute to large languages, like in most of the cases, it is either you're working for these large organizations like Meta or so on and so forth, or another way is you might be working around the tooling around it, but not just the foundational model itself. So what's the problem with the definition of open source and the large language models? When it comes to code, there is no disagreement. Like, everybody says this is a piece of code, there's a copyright bound to that code, and that copyright could be bound under any of the open source licenses, Apache, GNU, GPL, anything. But large language models are not just code, right? So there is a huge disagreement in the communities about what is the data which is used for training this large language models. Should the data also be open source? Okay, most of the so-called open source large language models could be training on proprietary data also. Okay, especially when it's coming from larger companies. And the third thing is the models. Okay, what would be the license of the models itself? So what happens in these two things is, from code there is no disagreement. The open source community gets what is the open source code and no. But when it comes to data of what is being trained for the models, there is huge disagreement, saying that the one set of audience saying that even the data should be open source. It should be open data sets on which it should be working on. And the third thing is a model. So certain models already, it's improving. Many open source models are putting up like Apache license or any other definitive OSI compliant license for releasing their models. So there's a huge improvement from what it was a year ago before. So usually what happens is most of the open source software versus open LLMs. There is a, like, right now most of the open LLMs have a regular release cadence. There's structured releases. The cadence is also getting smaller and smaller because the models are getting better. So many things are evolving in the developer side about, how do we work with these models like RAGs and agentic and prompt engineering, different ways in which they can interact. And most of the open source projects, you can directly go put a PR and contribute to those projects, but that's not the case with most of the open source large language models. You just can't go to that project and put a PR for contributing to the project. So what Instruct Lab does is, so when you're saying open source large language model, there are different steps. One is the training data, what data sets. Pre-processing, what is the filtering criteria, and what is the code used for filtering criteria. And the third thing is the training of your model. Is that code also open source? And models, when you are talking about models, the architecture, the trained weights, and the evaluation results, all of these things need to be published. And from the deployment point of view, again, what is a fair usage policy if somebody is using that in production? Yes, if you're doing it for development, many open source models are flexible, but if you're taking it to production, that's where a lot of problems are happening because of the commercial usage of it and from the indemnification usage of it. Like, so for example, if you're generating code out of a large language model and you put it in your software which is bound for an audit, is it okay by your organization and is it okay by the license? So these are a few of the things which you need to keep in mind while doing open source, while consuming open source large language models. Say, for example, Llama itself, there are quite a few variations of Llama which has come out over the last year. Like if you just take a look at Hugging Face, there are more than 40 Llamas. Which Llama you want to contribute to and how does that contribution get back to the actual project? So these are a few of the things. The way it is saying is you're taking a base model, you're using your knowledge or a certain skill for training a base model. So Instruct Lab gives you a way in which you can have in a normal question and answer format so that it's not just the developers, anybody within an organization can contribute to the foundational models. So it provides you a way in which you can generate out synthetic data out of this question and answer format. And this format is basically in a YAML file. So take a look at the project. We're also having a BOF on open source large language model starting in another 5 minutes in front of Audi 3. Thank you. Sure.
Thank you so much. Next up, we have talk from Jyoti.
Hello. So good afternoon, everyone. My name is Jyoti, and today I'm going to be speaking about accelerating India's open science journey by using Python. So I am Jyoti. I'm based in Pune, India, and I have been trained as a statistician. I wear multiple hats, which include being a website developer and a community manager. So what is actually open science and why is it important? So open science is the idea of making scientific research open and accessible to all. Now, it is based on the principles of making knowledge transparent, inclusive, and democratic. Why is it essential? This is also tied up with United Nations goal for good quality education, which is the goal number 4 for sustainable development. This promotes free and equitable access to scientific knowledge and resources. The challenge over here is that the scientific knowledge generated mostly stays in silos, and therefore there is a lack of collaboration, which leads to non-accessible scientific results, which then leads to non-inclusivity. However, the good thing is that India has been developing open science policies around the Sustainable Development Goal from United Nations. If you want to know more about it, you can check out UNESCO's recommendations on open science. So there are 4 pillars on which open science is built up. What connects it to this conference is the open tools and open software pillar. This can be achieved by using technologies like Jupyter Notebooks and GitHub by using which the code bases, data can be shared with people. The second pillar, which supports open science, is open data. So by making scientific data open, by using projects like GeneBank, DataOne, data can be made open. There are the third pillar, which is the basis for open science, is GitLab, by using open code, by using GitLab and Python libraries. And the fourth one is publishing the results in open access journals rather than publishing them in closed access journals. And some examples of open access journals are PLOS and Archive. How Python helps here is due to its key features, which are ease of use, accessibility, versatility, open source code, and the active support from the community. Some of the Python packages which help making science open are NumPy, Panda, Matplotlib, right from data analysis to data visualization to scientific Python. If you want to know more about the case studies which are on the recent advancements in India, you can take a look at reports from Core Asia Open Access Meeting, which was conducted by Confederation of Open Access Repositories recently in Delhi in April this year. You can also take a look at the report from G20's Chief Science Advisors Roundtable reports. So the key takeaway that I want you all to take from here is that open science, along with the support from open communities like Python, is what will empower India's scientific progress. That's all from me right now. If you want to connect with me, you can scan the QR code, and I will be around today and tomorrow. You can speak to me. Thank you.
Next up, we have Hitesh.
Hey guys, my name is Hitesh, and I'm a senior software engineer. So before I start this talk, a quick note, do not get offended. It's a lightning talk, it's supposed to be light, so take it lightly. So debugging is just a fancy word for looking busy. When we talk about debugging, it's like if you are a developer, in a week, couple of times you are sitting on a screen and figuring out why does this not work. It should work, right? It was working just a couple of minutes ago. But you're like engrossed into your screen and your PO walks behind you and looks like this guy is doing something very serious. He's solving like complex algorithms or something. But let's be honest, you and me both know you're just staring at the screen, right? So let's break it down. If we talk about debugging, 90% of the times you are just staring at the screen, 5% of the times you are browsing through Stack Overflow, and the rest 5% you're just inserting sprint statements in the code and running it again and again. That's how debugging looks like. So this is the classic debugger's routine. Denial. It was working 5 minutes ago, but it's not working right now. There's some weird thing going on. It's not my code. I've not done anything wrong. But there's something weird that's going on, but it's not my code. Then you start accepting that something is wrong with the code, maybe not what you did, but maybe it's a config file that was just changed. Somebody else pushed something into the repo, and then you rebased it, and now something else is not working, but it's still not your code that's not working. You finally get into a point where you start accepting, okay, it might be just my code that's not working, and then you start with the print fiasco, wherein you start putting print statements on every other line that you pushed and entering this function. It should be here, still here, but it's still not working. And then finally, you go to Stack Overflow, you browse what is going on, and you're still at a place where you might not understand what's going on, right? So then after a while, like maybe a couple of hours later, you will not read the documentation, which takes 5 minutes. You will spend 6 hours
trying to figure out what's going on, right? And then finally you figure out what exactly was wrong. And then you have that aha moment and you feel great, you feel proud. Sometimes I feel prouder than getting a good percentage in my 10th. So that's how you feel, right? And when you do it, sometimes your PO gives you a shout out, sometimes your TL tells you, great job, whatever. My PO is personally very nice, so he sometimes sends me that crying emoji saying that great job, and I feel very proud of it. And then I push it to staging, and it doesn't work in staging, right? So it has happened a lot of times. Might be a config file again, which I forgot updating the config file and I deployed to staging, and it doesn't work. But then it was working on my machine. So there has to be something wrong with the environment, not me. So this was just a light talk, but then I want to focus on this point that it's not just looking busy. When you actually debug, when you actually spend time debugging, if you are early in your career, you will learn a lot of things. It sharpens your instincts. It makes you go through a lot of different approaches to debug, and slowly you build that mindset of learning how exactly and what exactly debugging is, and how exactly to have the right approach, the quickest approach, and not spend 6 hours. It develops your spidey sense in the code base. So if you're working with a code base for let's say 6 months or one year, you develop the spidey sense wherein you know, okay, if I do this wrong, it's going to cause an error, and I will have to spend hours and hours debugging, so let's not do this. It separates the good developers from the great ones. If you are the person that debugs everything, a lot of people will come to you and tell you, okay, can you tell me why this is not working? It happens a lot with me, and if you take a lot of bugs, they will come to you as well. So that's a great moment when somebody comes to you and asks you something, and then you are able to help them. So that I feel good about that. And it's a great tool for beginners. If you're beginning with any code base or anything like that, just go solve some low-hanging fruit bugs, and when you start debugging a bug, or when you start looking into it, you understand what the code base is, how it works, with very small steps. So these are baby steps that you can start with. And when in doubt, print it out. Thank you.
Next up, we have Mohit.
Okay, hello everyone, good evening. Today I'm going to be talking about the Zen of Python. This is something which was written in 1999, almost 25 years back. And you all must be wondering why, after 25 years back, we all are here to discuss about the Zen of Python. This is a set of 19 simple principles. So if I do import this in any Python interpreter, it will give me a set of 19 guiding principles which talks about how we should write Python code and how our code could be more Pythonic in nature. Simple rules started as fun, started as a joke back in 1999, but these are still relevant. Even if you look at any of the libraries, any of the Python project, even if you look at the good code, you will see they hold this property. We'll discuss some of them in a very brief fashion. Beautiful is better than ugly. The Python is known in the industry for its elegant syntax, for its easy readability, and easy understanding. And that's what you should maintain while writing down the code. Whenever you're writing a Pythonic code, you should ensure that those things happen. Explicit is better than implicit. The best example is you should avoid having those args and keywords and just putting out random variables like those. That makes code hard to understand. You should have code as much as explicit, easy to understand as far as possible. Simple is better than complex, complex is better than complicated. Again, a guiding principle, we should follow for the simplicity, because we are not writing the code just for computers, but for other developers, the following developers, to come and understand. So always when you're writing down the code, think whether a fellow human can understand or not, and not just about whether a computer can understand it or not. Flutter is better than nested. Again, a guiding principle again on how you should structure your directory. Having too many submodules and modules inside it might not be a good idea. It's always better to have a flat structure as far as possible. Readability counts. This is the most important, as I mentioned. It's all about readability. If you're writing down the code, just think about if I come back to the code after 1 year, whether I will be able to understand or not. It is the readability which matters a lot. Next two principles are correlated, which is the special cases aren't special enough to break the rules. We all have this dilemma. We all think, oh, this is a special case. Let me write down a new class for it. Let me write down a new if cases for it. Let me handle it in a different way. Just take a pause. Just think about it. Those special cases might not be those special that you are having enough to break the rules. But the next statement goes a little contradictory. Sometimes for a practical purpose, you might have to break those rules and go for some ignorance over there. Error should never apply silently. It does not, the best way to understand it, go into production, let the code fail, and you're not able to debug it because there's no logger, no things pointing you out. So always never ignore your errors and let them pass silently. Again, the next thing goes hands on hands with, there are certain cases where you might need them or you might want them to go silently. I will quickly jump onto the next one. Although now is better than never, and although never is often better than right now. Python is known for its prototyping things. You can quickly do a prototyping over here. So instead of having a procrastination and thinking of let me do it later, you should always think, have a quick prototyping in Python. But the next statement also says about take a pause, think about it, spend some time, try to see if you're not reinventing the wheel, is there any existing solution, and then go for it. And then only goes about it. Again, these are the guiding principles. These are not a hardcore rules as such. Started as a joke back in 1999, but might be still relevant. So next time when you're writing down the code, working with any Python code, you're not able to make a design choice, you're not able to think which is good, which is bad for me, just go through this principle. They might guide you, they might enlighten you what could be the best call taken for you. That's it from my side. Thank you, have a good day. Thank you.
Thank you so much, Mohit.